So we've covered our weathering processes and reactions. We're going to now push that into the realm of soil formation or soil genesis, how soils develop. And there are four generalized processes that happen within soils to result in all of the properties that we see within the soil. We're later going to talk about soil forming factors. Don't get these confused. These are the processes. These are the actual changes happening. The factors are kind of the things causing those changes. So we'll keep that straight. But right now we're focusing on the processes, the actual processes happening in the soil to produce the horizons that we see, the things that we've described already. Those four are up on the screen here: additions, losses, transfers, and transformations. So we will talk about those in greater detail. We'll start with additions. And with additions, we're talking from outside of the soil, something external, bringing something in. And some great examples of that are shown on the in the pictures here. Vegetation, litter in a forest floor here. We've got this woody debris and leaves. Those are things coming from outside of the soil, coming to the soil surface and being added to the soil. There's definitely some cycling going on. The components of that were maybe once part of the soil, or at least some of them, and so there's kind of some back and forth, but that's an addition. It's outside of the soil. This above ground vegetation falls on the soil surface and gets integrated into the soil. Down in the middle picture here, this is not just a bad photo, this is dust, right? Dust blowing in from somewhere else. Maybe it was part of a different soil, but it's being brought in and dropped on the soil that we're interested in. And here in this hole, this soil pit, we've got it filling up with groundwater. And so groundwater can bring in a lot of material, dissolved material primarily, but those dissolved constituents can be an addition to the soil. The flip side of that is going to be the losses. Erosion is the main loss that we think about. Water erosion or wind erosion, we're removing soil material. That's an example of a loss. Another loss that's harder to illustrate and show a picture of, but you can leach material out of the soil. You can dissolve it and wash it out through the bottom of the soil down into groundwater. So groundwater can bring things in, but it can also be the receptacle for stuff that has leached through the soil and washed out of the profile, and then can be removed in that flow of groundwater. Transformations. This is probably the most complicated, one of the most complicated, more conceptually complicated than adding or losing something. This is fundamentally changing something. So chemically or physically transforming something. We destroy a mineral, we synthesize a new mineral. Think chemical and physical weathering reactions that we've just talked about. Here's an example. This is one that you actually saw on the hydrolysis slide. You didn't have the full formula written out like this, but this is a potassium feldspar. If we add some water and a little acid, we're splitting some of these waters and forming kaolinite clay. This is one of the most common reactions on Earth. It's maybe not one you've studied before, not one you see in a whole lot of other classes, but the weathering of a feldspar to a clay is happening all the time across the globe. All you need is a little water and a little acid. And then we're producing some other constituents on the other side, but we've transformed that mineral. Second example, forming organic acids, humus that we've talked about during microbial decomposition of organic matter. Transforming those organic constituents is a transformation. Translocations. I think on the previous slide I called it transfers. Same idea, we're moving stuff around. So movement of material up or down or laterally somewhere within the soil. So if it's coming from outside coming in, that's an addition. If it was in the soil and it's lost completely out of the soil, that's a loss, but this is just moving it around from one horizon to another. So within the profile, moving stuff around. That can happen through physical mixing. This soil here is in Alaska, and it's a permafrost soil that freezes and thaws and mixes from all of that. It's called cryoturbation, from that freezing and thawing. It's moving stuff around physically. So that's a physical movement. Here, this soil, things have been moved around through chemical reactions. Things dissolve, they move, they reprecipitate, and so there's some chemistry going along that is allowing things to move around into these really distinct zones. We have moved stuff out of this white pocket and moved it into the dark black and dark brown zone. So moving stuff around within the soil, translocation or transfer, same concept. So those are the processes. At the surface level, not too complicated, getting into all of the reactions that are happening for some of these transformations, and then allow for translocations to take place. It can get very complicated very quickly. For now, we're just going to keep it at the broad level, the general level, those kind of 4 sets of processes. And those produce the horizons that we've talked about already. We're going to add a little detail to some of those terms that we've seen and give you the sub-designations, a few sub-designations that tell us a little more detail about our horizons. And those often are telling you about what processes have taken place. For an A horizon, you can't have just a regular A, but you can also, especially in cropland, this is very common, you can have an AP. You can tell that this is cropland because you can see the corn residue up on top, right? And somewhere down in here, looks like we have this very distinct line from this stuff that looks kind of all mixed up to the stuff below, which does not. That's because this has been plowed. So P is for plow, physical mixing of that surface horizon. Which process has taken place? That would be a translocation, right? Physical mixing. We've moved things around. Next up, clear my notes there because I actually have it written out for you. Same soil, but down in this zone, our subsurface zone of alteration, that's a B, right? The little t is for clay. So we've accumulated clay there. What processes would allow for clay to accumulate subsurface? Transformation. We're doing those hydrolysis type reactions commonly that are transforming things like feldspars into the clays. We have to create the clay. And also translocations, transfers. The clay is, a lot of those reactions are happening up in the surface. That's where most of our CO2 is, right? That's where a lot of the organic activity is taking place. So we're doing the weathering up on top, but then we have water pushing things down as we have precipitation. And so the stuff moves out of the surface, gets to the subsurface, and accumulates in our BT horizon. Clay accumulation is a super important process in soils. Soils are clay factories. We're constantly producing clay. It takes a long time, but the more clay you have, that is telling you something about how developed the soil is. So we have to transform to create the clay, and then we have to move it around. It can also come from additions. A lot of the dust that blows in is very fine, and so maybe we've added some clay through the additions process as well. Oop, jumped ahead. BK. So again, we've got a B horizon, but this one has a different alteration. Its subsurface is altered, but in a very different way, and the K is for carbonates. I know it's not quite there, C got used for something else. So carbonate accumulation, that's a different material that's accumulating under very different climates, but also an important change that can happen. What processes are functioning? Transformations, carbonation type reactions, dissolution in one part of the profile and reprecipitation in another. So those chemical weathering processes are transforming some of our carbon-bearing constituents, our carbonates. And then there's going to be a translocation, moving it and concentrating it in one zone. Here's a BH. H, think humus. for organic material. It's illuvial organic accumulation. Illuvial means it has moved through water pushing things around or soil solution. It's been translocated within the soil through leaching from the overlying E horizon, right? That has had eluviation. Things have exited. The opposite is illuviation. Things come in to the illuvial zone. And so the illuvial zone is accumulating material that washed out from above. In this case, we've accumulated organic material. This up on top where it's dark, we've got a lot of organics there. They have been washed out of this zone and accumulated in our BH. So H, think humus. Humus is organic material. This one is a BQM, and the Q is not a letter I'm emphasizing, but you have to have a letter to go with M. M is for cementation. We've basically transformed it into a rock-like material. We've cemented it with some kind of agent. The Q means silica. I'm not emphasizing that. That's not what I'm going to put on the quiz. But M is for cementation, where we've transformed that underlying horizon by translocating this silica material. Common theme, hopefully you're seeing in our B horizons, we often have some kind of transformation that creates a constituent or makes it mobile, and then translocation that moves it into the horizon. So very commonly, B horizons are altered by moving something in. BN. N is for nater, which is the Latin word, I think, for sodium. So the symbol for sodium is Na, right? So think sodium starts with an N in its atomic representation. So N is for sodium. Again, we've got to translocate it. Sodium is pretty soluble by itself. You may not have to transform very much. Probably some kind of dissolution reaction makes it mobile, and then it moves within the soil. O is for oxides. Think oxidation. And these oxides accumulate not because they've been added or illuvially transferred into the horizon. They actually accumulate because oxides are so resistant that they get left behind. These are super weathered soils. Everything else has been weathered out of it, basically. We've broken down every single mineral that we can, and what's left behind is a pile of rust. And that rust, these oxides, are just not very mobile. So this one, it's a transformation that creates the oxides, and then there's been a whole lot of transfers and losses from that soil that leaves these oxides behind. Our next letter is for G. O is oxidation, G is for glazation. So reduction. We've reduced our iron and either gotten rid of it altogether because it was mobilized, or it's still there but it's in that reduced form. And so we glay with an L is the process. Glade soil has been glayed. It's gone through that glazation process. It sure sounds a lot like gray, and that's convenient because it is, but slightly different term there. And sometimes it's a little blue or a little green. There are other glade hues. This is a transformation. The reduction reaction is transforming our iron. And then sometimes it's a loss, sometimes it's a transfer, or sometimes the iron is just still sitting there. It's just transformed in place. And Z is for salts, which you could imagine pronouncing salts. So soluble salts that have accumulated. This is going to be in a pretty desert-like environment. What types of reactions, what types of processes do you think would produce a BZ horizon? Hopefully you thought dissolution, salts dissolve, and then when they dissolve, that the dissolution and reprecipitation is kind of a transformation, but it's also concentrating in one zone. So it's going to be primarily a translocation, a transfer into that zone. Wherever the water stops, in this case we've got water down at the base of the soil, and that water, through evaporation, this is a desert environment, and we just happen to be near the water table at a low point, that water is wicked up through the soil, and it brings its salt with salts with it, and leaves the salt behind when it evaporates off the surface. So they're translocating salt. There's probably also some addition going on in this groundwater, bringing salt in to this zone from other parts of the landscape. One more subdesignation on our Bs, and that is the W. W, think weak. It's some other alteration, but it doesn't qualify as anything else. And so those BWs, weak alteration, a little something has happened, but just not enough to really say, well, it doesn't really have enough clay to count for a T, doesn't have the carbonates for a K, it's not gleyed, it's not oxidized, it's just the color has developed a little bit, or the structure has started to form. Something has changed, but it's weak change, not enough to get another letter. That is the BW. So lots of different Bs. B is subsurface alteration, and every B has to have a little letter to tell you how it's altered. That's just a subset to get you some of the most important, especially locally relevant ones, and some that represent some major processes. For Cs, it's a much smaller list of possibilities, and actually there's only one I'm going to show you, and it's by far the most common. If you're going to have a C, it's usually either a C plane or a CR. CR is for soft weathered bedrock. There's a term in the text, saprolite, which is essentially equivalent to this. And in this soil, you can see that you can still see the layers. This was a shale in here, and you can still see that rock structure. You can see all the layers of that original rock, but it has weathered in place so much that now you can just dig right through it with a shovel. It's no longer an R, or a capital R, because it's not hard bedrock, it's soft weathered bedrock. It's falling apart, but it still looks like the rock. That's a CR. A lot of, without the little r, you can just have a plain C. That's just sediment. It wasn't ever rock. But if it's was rock that has weathered enough that you can dig through it, so it's no longer hard, consolidated, that's the CR concept. So I'm going to not take the time again in the video to give you all the answers, but give you a little bit of a challenge to think through some of these layers, what the designation would be, and what processes have taken place. I'll give you a start on this one as an example. I might pause and make a couple comments on some of these. What horizon is this? It's one you've seen before. It's an A, right? Surface darkened by organic matter, that's an A. What processes have taken place? In the generalized concept, how do you get it darkened? By organic matter. Where did the organic matter come from? Not from the soil itself. It came from the plants growing there and putting their roots down into that zone and leaking carbon into the soil. So that's an addition. That organic matter coming into the soil is an addition. But then that organic matter gets processed by organisms in the soil. It gets humified, and so it doesn't look like bits of roots anymore, right? It's been transformed. So there's a transformation of this addition. We add the material, then we transform it. So those are the processes in an A horizon. I was about to tell you, I'll give you a moment to check yourself. What horizon is this? It's an E, correct. What process dominates in an E horizon? I basically told you in a previous part of this lecture. Check your notes, check your understanding, see if you have that mastered. B horizons. What process has dominated? Also, let me add some information. This horizon on the left has a lot of clay that has accumulated. This horizon, has a lot of carbonates mostly calcium carbonate, that has accumulated. So what's the designation for each of these? The big letter and the little letter, the master and subordinate designation, and what processes have produced those. This one we just looked at, but refresh your memory. We didn't talk specifically about the processes very much, so I'll let you do that yourself. What's it called? What does that mean? What processes have taken place? This one we looked at previously. We gave you the designation. What are the processes, generalized processes that form this type of horizon? And lastly, this one you can't even see all of it because my little video in the corner is blocking a little bit. But this is one that if you want to take a few minutes, look at the slides online, read through each of these, and think about what soil forming process or processes are being described. I'm not going to read through them all. I don't want to make this video that long, but this is a good opportunity for you to go spend a little time on your own. Make sure you've got a good handle on this. So we've talked about physical weathering, we've talked about chemical weathering, we've talked about our generalized processes, and as part of that discussion introduced some more nomenclature, our subordinate designations for our horizons. So any questions you have on that, some of the review stuff that I've thrown at you but haven't answered here, talk it over with people in the class. If you know anyone taking the course, see if you can sort out some of these if you can't do it on your own, or come to office hours, email. Make sure that you're able to answer those and don't just blow them off, because that will help solidify your understanding. All right, we'll see you next time.